Hello students, I hope you all are doing good and preparing well for KCET exam. So only 2 days are left for your exam. So in today's session, I have brought you all Matrices and Determinants chapter. So we will be solving PYQ questions from this chapter. So this chapter has a weightage of around 6 to 7 marks. Okay, so this has got a lot of weightage and this chapter is comparatively easy when we compare it with integrals or differentiation. Because there are many you have to practice a lot to get to score better, but here there are only few rules that you need to know, and using that you can solve questions from this chapter. So this is a scoring chapter. I would suggest you to solve the questions on your own. Pause the video and try to solve it. If you're not able to, only then look at the solution. You can also find the PDF of this PPT attached in the pinned comment, so you can download that and try to solve the questions. Okay, so let's start today's session. Okay, so what have we got? So they have given us a matrix, square matrix A, alpha 2 2 alpha, and they are asking us the determinant of A cube alpha. So here the time consuming approach would be to find out A cube and then find the determinant of that. That is going to take a lot of time. The smarter approach would be, we know this property, right? Determinant of AB is equal to determinant of A times determinant of B. Okay, we know this. Can I apply the same property here? A. This is nothing but A cube. So this I can write as determinant of A, determinant of A, determinant of A, which is nothing but determinant of A whole cube is equal to. So what is the determinant of A? Determinant of A is alpha square minus 4. So this is my determinant. So we have got this is equal to 27. Okay. So alpha square, sorry, I'm so sorry. Okay. So determinant of A is alpha square minus 4 and cube of this, right? See, I have done it directly. This is your alpha square minus 4. Okay, this I have substituted here. So now taking a cube root on both sides, 27 1 by 3, alpha square minus 4 1 by 3. What do I get? I get 3, right? So alpha square minus 4 is equal to 3, alpha square is equal to 7. This means alpha is equal to plus or minus root 7. So our correct answer is option D. So in the smarter way that we used was using this formula. Okay, using this formula we wrote what we did. The main important step of this question is we wrote this as determinant of A cube. So this was the catch for this question. So this way we can solve this question in a faster way. Okay, moving on. Sorry. Okay. Yeah, evaluate the determinant directly, direct question. So they are asking us determinant, multiply these two and subtract them. So we get cos 15 cos 75 minus sine 15 sine 75. What is this? This is in the form of cos A cos B, cos A cos B minus sine A sine B, which is nothing but cos of A plus B. 15 plus 75. What is 15 plus 75? Cos 90. What is cos 90? Cos 90 is 0. Correct answer is option A. So this was a very easy question. One more thing, I have only picked up the difficult questions. I have not picked all the PYQs. Okay. So if x comma y comma z are all different and not equal to 0 and so, then the value of x inverse, y inverse plus z inverse is equal to. Okay. So here in these type of problems, you need to reduce this. Okay. You have to apply some column or row operations and try to reduce the given determinant. So how you can do this? Simple, right? Looking at that, you can make out few things. So what I am going to apply? I am going to apply R1 is equal to I would like to apply C1. I'll apply column operations here. That looks easier. I'm applying C1 is C1 minus C2. Okay, what do I get? X minus Y 0. Next, I'll apply C2 is equal to C2 minus C3. I'll get 0, Y minus Z, 1, 1, 1 plus Z. Okay. Now to find the determinant of this, it is easier, right? So I'll directly find the determinant. Using the first row I'll find. So x times y 1 plus z minus z plus z, 0 is gone, 1. So for this one also only this term I have to consider, yz. Okay, this is equal to 0. So what I get, x yz uh, yz xz. One second, yx, right? Yx, yeah, yx plus yz is equal to 0. So here I can do xy plus xz plus yz equal to minus xyz, dividing by xyz on both the sides. What do I get? I get 1 by x plus 1 by y plus 1 by z is equal to minus 1. So that is the thing. I have done slightly faster here. If you simplify this, you'll get it. So what we have done, we have given determinant, we have reduced it using some column operations. So we got it in a simpler form. Now to evaluate the determinant, it is easier, okay, because we have zeros. Try to make the elements of the matrix 0. So that will help you, help you to evaluate the determinant faster. Okay, that should be our objective. Okay, so this is a very important question. You can expect a similar question on this concept. Okay, so you need to know this concept crystal clear. If A is any square matrix of order 3 cross 3, then 3A is equal to, okay, so A, let us take determinant of A is K. Okay, when I multiply 3A to find the determinant in terms of this, I have to take, we know, right, in determinants, if we take common, so 3 is multiplied to entire matrix. So I'll take 3 common from each row. From first row, if I take, I have to take it out from the second row, from the third row. Then I am left with my determinant of A. So this is nothing but 3 cube determinant of A, which is nothing but 27. So this is how you solve. The general formula for this is determinant of NA is equal to uh, determinant of NA is equal to n to the power of, sorry, I'll take it k. Determinant of Ka is equal to k to the power of n determinant of A. Let me rewrite this. Ka is equal to kn determinant of A, where n is the order of the matrix. Order of the square matrix. Order of square matrix. You can remember this. This is a very important result. Okay, just remember this, apply this. So this is 27 determinant of A, which is nothing but option C. Moving on. Okay, so this is a direct similar question what we did previously. They are asking us the direct formula. We did, right? So Ka, we have to take K common from each row every time. First row, second row, third row. So we'll get K cube determinant of A. So the correct answer is option D. Okay, moving on. Yeah. If A is equal to 1 by pi so and so, B equal to 1 by pi so and so, then A minus B is equal to. So if you look at the question, this seems difficult, okay, but see what they are asking. They are asking us A minus B. Okay, so what do I get on A minus B? So these are matrices, okay, not determinants. These are matrices. So but term wise I have to subtract, right? 1 by pi is common, so term wise I just need to subtract. So what do I get? Sine inverse pi x. So this is minus cos pi x, so it is becomes cos inverse pi x. Similarly here, tan inverse pi x minus tan inverse pi x. So this gets cancelled because we are doing minus A minus B, right? So this gets cancelled. So this is 0. Similarly, sine inverse pi x minus of sine inverse pi x, this will also get cancelled. Cot inverse pi x minus of minus tan inverse pi x, that will be nothing but plus pi x plus tan inverse of pi x. So tell me, from inverse trigonometry, we know that this is equal to pi by 2. This is pi by 2, right? Direct property. 0, pi by 2. So this is a matrix. Okay, remember, this is a matrix, not a determinant. From this matrix, I can take common pi. I can take pi by 2 common. What do I get? I get identity matrix. Pi gets cancelled. I get 1 by 2 I. Okay, 1 by 2 I. So the correct answer is option D. Yeah. Okay. Yeah, coming to our next question. If A is a square matrix of order 3, determinant of A is 5, then A determinant of A adjoint of A is equal to. Okay, how do I solve this? This is the standard result that we know. Okay, let me just write that A adjoint of A is equal to determinant of A times I. I know this formula. If I take determinant on both sides, okay, if I take determinant, I have to take this A. A is a constant here. From each row, I have to take it common, right? So I have got a 3 cross 3 matrix. So this will be A, Q, I, right? And I can write this as like this, right? Determinants can be written like this. I is nothing but I can just ignore. So adjoint of determinant of adjoint of A is nothing but determinant of A whole square. What is determinant of A? They have already given us 5 square. So the correct answer is 25. So here the standard result that you need to know is, I have done wrong. Sorry. They are not asking us the determinant of adjoint of A. They are asking us this thing. No? That is nothing but determinant of A whole cube. So determinant of A is 5. 5 times of Q is 5 is a 25. 25 5 is a 625. So the correct answer is option D. I'm so sorry, guys. Okay, so this is how you can approach. There are shortcuts that you can remember, but I would suggest you to go through concept method so that you don't have to memorize much of the things. So you should enjoy the things, right? So try so that you are able to solve them using concepts. Okay, so that is going to help you a lot. Try to avoid shortcuts, I would say. Try to build your concept more. Moving on. Okay, if A is a matrix of order mn and B is a matrix such that AB transpose B dash is nothing but B transpose. AB transpose and B transpose A are both defined. A, B transpose and B transpose A both are defined. The order of matrix B is. Let us take order of A as m cross n. Okay, both the multiplications are defined. Both the matrix multiplications are defined. That means A m cross n. Let us take the B transpose order as PQ. Okay, so B transpose as PQ. If this is defined, n is equal to P. Okay, this should be equal. N is equal to P. Similarly, for the second case, I have got P cross Q and A is m cross n. Again, this is defined. That means these two are equal. That means Q is equal to m, right? So substituting the values, what I have got, P is equal to n and Q is equal to m. So B transpose is nothing but n cross m. Then what will be B? B will be reverse of this, m into n. So the correct answer is option D. So simple, okay. Simple steps, 2 or 3 steps you have to do. You can easily solve in 1 minute. Moving on. Yeah. So this is a good question. The value of a third order determinant is 16. So what does this say? So there is a square matrix that is of order 3. So we have got a 3 cross 3 matrix. The determinant is, say it is A, the determinant of A is 16. This is what they have told us. Then the value of the determinant formed by replacing each of the elements by its cofactor is. Okay, so they are twisting us. So they are telling us cofactor matrix. Okay, this is a cofactor matrix, A11, A12, A13, so on. So this is our cofactor, but this is not our, this is the cofactor matrix. Okay, so what will be the determinant of cofactor matrix? What we know, say let us call this as B. Okay, we know that B transpose of cofactor matrix is adjoint, right? Adjoint. Okay, this is nothing but adjoint. So determinant of B transpose is equal to determinant of B. We know this property. So indirectly they are asking us the determinant of adjoint of A. So what is the formula for adjoint of A? There is a direct formula that you can use. So that is determinant of A n minus 1. So this is the standard result. This you can derive also. It will take hardly 2 steps to derive, but I am doing it directly. So n is the order of the matrix. Determinant of A is 16. N is nothing but 3. They have given us third order. They have mentioned it. Okay. So 3 minus 2 is 3 minus 1 is 2. 16 square is 256. So the correct answer is option B. So it is a trick. So see. Then the value of the determinant formed by replacing each of its elements by its cofactor is. So this is our matrix. So they are asking us determinant of this. Let us call it B. So this is the cofactor matrix. But what we know, Adjoint of a matrix is nothing but transpose of cofactor matrix. Okay, so B transpose is nothing but adjoint of A. B transpose is adjoint of A. So determinant of B transpose and determinant of B is equal. This is a property of determinants. So directly if I find what is determinant of adjoint of A, I'll be able to find the answer. Okay, that is how you can solve these type of problems. This is a slightly tricky question they have asked. It is a good question. Moving on. Yeah. So yeah, in case of determinants, what you have to do, you have to just simplify. Try how you can reduce it. So looking at this, mostly go blindly apply these row operations. R1 is equal to R1 minus R2, R2 is equal to R2 minus R3, anything. Go and apply this, you will get something. It will be reduced to some form and then you can easily find. Let's apply R1 minus R2. R1 minus R2, I get log x minus log 2x log y minus log 2y log z minus log 2z. Similarly, R2 is R2 minus R3 log 2x minus log 3x log 2y minus log 3y log 2z minus log 3z. This is the same, right? Log 3x log 3y log 3z. Okay, so here we need to apply properties of logarithm. Log x minus log 2x is nothing but log a minus log b is, tell me what is log of a minus log of b. What is this? Log a by b, right? Same thing I'll be applying. So x gets cancelled, I'll get log 1 by 2, right? Similarly here also I'll get log 1 by 2, log 1 by 2, and here I'll get log 2 by 3, log 2 by 3, log 2 by 3. Okay, I can take common, right? I can take log 1 by 2 common and log 2 by 3 common. What do you observe here? Third row I have just ignored. I'll get two rows same. What happens through the determinant if I get these kind of things? Two rows are same. That means the determinant is 0. Okay. Which of the options says it is equal to 0? Yes, option C is 0. So the correct answer is C. So C, you have to just apply some row operations or column operations and then try to simplify it. This is the only thing that you can do to solve these type of questions. Okay. Simple. Moving on. If A is equal to so and so and A plus A transpose is equal to identity, where I is a unit matrix of 2 cross 2, A transpose is a transpose, then the value of theta is equal to. Okay, so here what you can do is they are telling that addition of these two is I. Okay, what is I? 1 0 1 0. So here the trick that you can do is you can only evaluate the first one, the first term, that is A11 of A plus A transpose. Okay, no need to evaluate the entire thing. A they have already given us. What is A transpose? Cos 2 theta minus sin 2 theta, sin 2 theta, cos, one second, sin 2 theta cos 2 theta. Yes, so this is our A transpose. A transpose plus A, what do we do? Element wise we add this term with this term, right? So that will be my first term, that is nothing but 2 cos 2 theta. Okay, so I'll just equate these two. Two matrices are equal, their corresponding elements will also be equal. 2 cos 2 theta is equal to 1, cos 2 theta is equal to 1 by 2. Tell me what is the angle? 2 theta is cos of 60 is cos 60 is 1 by 2. Yes, 60. So theta is equal to 30. What is 30 degrees? Pi by 6. So the correct answer is option A. So this was an easy question. No need to evaluate the entire thing. A plus A transpose, no need to do. Just the first term, if you evaluate, equate it to the corresponding, because using the equality of matrices, we can do that, right? So this is how you can solve it faster. Yeah, if A is equal to so and so, then A square minus 5A is equal to. Okay, look at the options. I, minus I, 7I, minus 7I. Same here. Here also I'll be applying the what I applied in the previous question. We will be only evaluating the first term of this. What will be the first term of A square 5A? Just the first term. This will be a 2 cross 2 matrix, right? But I will be only finding out this term. Okay, if I find that term, I can tell which of the option is correct, right? So in A square, I'll just find the first term, 3 minus 1, 1, 2. 3 1 minus 1 2. So it is nothing but 9 minus 1, 3 3s are 9, one second, 3 3 minus 1 minus 1, 3 3 9, 8. So this is 8. So 8. So I am just evaluating the first term. Okay, 8 minus 5a. 5a is 5 3s are 15. So what am I getting? I am getting minus 7. We have just evaluated the first term. Okay. So looking at the options, I know the first term is minus 7. In I it is not there. In minus I it is minus 1. In 7I it is plus 7. In minus 7 it is minus 7. The first term will be minus 7 for this matrix. So just by evaluating only one term, okay, one term of the solution matrix, we are able to find out the solution. So this is a smarter way of solving. Okay, no need to evaluate the entire thing. Moving on. Yeah, again. So yeah, we have got ax x square 1 a b y so and so. This is delta 1. We need to find the relation between delta and delta 1. Okay, looking here, see, ABC is in column here, but here ABC is in row. So first thing I would do is I would take a transpose. I am concentrating on delta 1. Okay, I'll take transpose. On transpose nothing happens. Okay, ABC XYZ ZY ZX XY. Okay, multiplying by x on the first row, and I have to divide at the same time. Okay, if I multiply, this is a determinant. In the second row I want to multiply with y, I have to divide, right? In third row I am multiplying with z, again I have to divide. So looking at this, I can take xyz common. If I take xyz common, xyz by xyz is equal to ax x square 1 by y square 1 cz z square 1. So this is nothing but delta, right? So delta is equal to delta 1. So this will come with practice. You need to practice. So here the important thing was observing this. ABC is in column and ABC is in row. That means something related to transpose. Okay, so I did the transpose. Looking at the transpose, everything was crystal clear to me. I just went on and simplified. That is how you can solve the question. Moving on. Okay, so if a is, then what is a power 4? Okay, so first let me check what is a square at least. Okay, 0 0 1 0 1 0 1 0 0 0 0 1 0 1 0 1 0 0. So what do you get? 1 1 1. Okay, 1 1. This is 0 again. Yeah, 0 0 1 0 0 0 1. So I'm getting I. A square is equal to I. That means a square into a square is equal to I square. I into I. I into I is I square. I square is I. So the correct answer is option C. Simple question. Okay. Moving on. Okay. If a matrix A is both symmetric and skew symmetric, then okay. Uh, when is a matrix symmetric? When Aij is equal to Aji. Okay, this is the condition. When is the matrix Q symmetric? Aij is equal to minus Aji. Okay, let us take one number. Say it is equal to 2. Okay, then whether 2 is equal to minus 2, this condition will fail. Okay, it cannot be. So any number will not satisfy. But if I keep this 0, this also 0, then it satisfies. Okay, so every term needs to be 0. No other, if I keep any other number, these two conditions will not satisfy at the same time. If I keep 2, it will be 2 minus 2, 2 equal to minus 2. That is wrong. Only 0 will satisfy here. So the correct answer is A is a 0 matrix. Simple question, 10 seconds hardly. Okay, just tick and move to the next question. So whenever if this question is asked, a matrix A is both symmetric and skew symmetric, then it is going to be a 0 matrix. Okay, remember this. Moving on. Okay, so these type of questions, there is a method to solve. If P and Q are symmetric matrices of the same order, then PQ minus QP is. They have given us P and Q are symmetric matrices. From that, I can write that P is equal to P transpose, Q is equal to Q transpose. So now PQ minus QP, I'll take transpose. What do I get? PQ whole transpose minus QP whole transpose. So when we are taking transpose like this, I have to reverse this, right? Q transpose P transpose. Similarly, QP co, I have to reverse P transpose Q transpose. What is Q transpose? Q transpose, from here I can see it is Q. P transpose is also P. P transpose P, Q transpose is again Q. I can write this as PQ minus QP. Now observe, PQ minus QP whole transpose is equal to minus of this thing. If I call this as A matrix, A transpose is equal to minus of A, minus of A. What is this? So it is a skew symmetric matrix. This tells us that, the condition tells us that the given matrix, this matrix is skew symmetric. So this is how you approach these kind of questions. Okay, you can expect a similar question. Yeah, coming to the third question, if A and B are square matrices of the same order and B is a skew symmetric matrix, then A transpose BA is equal to, they have given us B is a skew symmetric matrix, so B transpose is equal to B. So same thing I'll be doing, A transpose BA, applying whole transpose. Okay, so first, if this is the case, reverse it, reverse, write this in reverse form, A B A transpose. Now apply transpose to each of the matrices. So what do I get? A transpose is nothing but A transpose only. B transpose is minus B. A transpose whole transpose is A. So what I get? Minus of A transpose B A. So what you can see? What you can observe here? This is a condition for skew symmetric matrix. So the correct answer is option D. So this was similar to what we did in the previous question. The property you need to know here is AB whole transpose is equal to B transpose A transpose. Remember this, very important. Similarly, for ABC whole transpose is equal to C transpose B transpose A transpose. Remember this, okay, very important. You can expect a direct question from here. Moving on, yeah. So here for this kind of questions, I would suggest a trial and error method. So they have given us what is A power n equal to 2 power k A, where k equal to, okay. Let us take n equal to 1. What do I get? A is equal to 2 power, I have to keep 2 power k A. So I need to make this term 1. That means 2 power k is equal to 1. That means k is equal to 0. This is one condition. Similarly, if I keep n equal to 2, what do I get? A square equal to 2 power k into A, right? So what is A square? I need to know. A square 2 4 plus 4 8, 2 2 2 2s are 4, yeah, minus 8 minus 8 8. So if you evaluate, you will get it. I have done it directly. So as you can see, A square is equal to 8. So in A you have these terms, right? 2 minus 2 minus 2 2. So what should be your 2 power k? 2 power k needs to be 4. Okay, 2 power k is equal to 4. That means k is equal to 2. So you have got two cases here. N is equal to 1, k is equal to 0, and n is equal to 2, k is equal to 2. Okay, so we have to see which of them satisfies. Option A doesn't satisfy. What about option B? Does it satisfy the first condition? If n is equal to 1, k is equal to, this will give us k is equal to 2. So no. N minus 1, let me check. If I put n equal to 1, I'll get k equal to 0. So first condition is satisfied. If for n minus 1, if n is equal to 1, if n is equal to 1, my k is equal to n minus 1, which is equal to 0. Okay, first case is done. What about the second case? N equal to 2, my k will be 2 minus 1, which is 1. Second case is failing. Okay, second case is failing, so this is also not correct. So the correct answer is option D. You can check that. I don't want to do that. You can check that. Both of these conditions are satisfied for this case. For what value they are asking us, what is the value of k in terms of in relation with n. So what we did, we took some simple numbers, we evaluated the values of n and k, and we are checking the options. Okay, this can be easily solved in a minute. Okay, moving on. Okay, if x1 comma y1, x2 comma y2, x3 comma y3 are vertices of a triangle whose area is k square units, then so and so. So you need to know what is the area of triangle. Area of triangle is given by 1 by 2 x1 y1, x2 y2, x3 y3, and 1 1 1. This is the area of triangle. This is the formula you need to remember. Okay, so here We will be changing this. Let's focus only on this matrix for now. X1, X2, X3, Y1, Y2, Y3, 4, 4, 4. Let me call this A. We need to evaluate A square, right? Let me call this B, okay? Not to confuse. We need to evaluate B square, determinant of B square. This is our B, right? This is our B. So B may, I'll take 4 common. I'll get X1, Y1, 1, X2, Y2, 1, X3, Y3, 1. Okay, now I will multiply and divide by 2. 1 second. Multiply and divide by 2. Okay, so this is my same thing, x1, y1, 1, x2, y2, 1, x3, y3, 1. So I have just multiplied and divided by 2. So this is nothing but my area of the triangle, which is k. They have only given us 4 into 2 into k. So this is nothing but 4 2s are 8, 8k. So this is only one thing, b. But our thing is this thing, right? They are asking a square. So mod b square is 8k whole square, which is nothing but 64k square. So the correct answer is option C. Everybody got this? Slightly, I have done it. This looks slightly messy. I'm so sorry. I want to finish this video as soon as possible. So I am in a hurry. I'm so sorry, guys. Okay. Yeah. If A is equal to so and so, B is equal to, then A, B, B dash is. Okay. Here again, we have to use the properties. A, B, B transpose is equal to A. We can take determinants of individual matrices. We know that determinant of B and B transpose is same. So here we need to find only two determinants. What is determinant of A? 2 minus 7, that is minus 5. What is determinant of B? 2 2s are 4. 4 minus gets plus 5. Yeah, 5 square. So this is nothing but minus of 5, 6, 25. 5 5s are 25, 25 5s are, no, I have done something wrong here. 4 4 1 minus 1. What is determinant of B? 4 minus of minus 1. This is nothing but 5. So what is determinant of A? 2 minus 4 3s are 12. No, sorry, minus 10. So this is minus 10. No? So determinant of A is minus 10. So I get minus 250, right? So the correct answer is option C. Oh, okay. So this is the last question, I guess. The constant term of the expansion is. Okay, here we have to apply our brain. Okay. Okay. So this is a determinant actually, not a matrix. This is a determinant. I'm sorry, guys. So here, if we evaluate this determinant, we'll get something like this: ax, maybe ax cube plus bx square plus cx plus d. Okay, we'll get in this form. They are asking the constant term. They are asking us constant term d. So for what value of x I'll get d? If I put x equal to 0, all these will become 0. I'll get only d. I'll directly get my constant term. So the smarter way to solve this would be put x equal to 0. So what do I get? What will happen to my matrix? It will be 3, sorry, 1, minus 1, 2, minus 1, 2, 1, minus 2, 1, minus 1. So I just need to evaluate the determinant of this. That will be the constant term. Okay. So what is the determinant? 1, 2 minus 2 minus 1, minus 1 plus 1, 1 minus 2 plus 2 plus 2 minus 1, 2 2s are 4 minus 4 plus 4. Okay, so this is minus 3 plus 3, 3 2s are 6. So the correct answer is option D. So this is a slightly trickier question. They are asking us the constant term. So if we expand that, we'll get it something like some cubic equation we'll get, right? So if I put x equal to 0, I'll directly get my constant term. So that is a trick that we used. Yeah, that was all I have got. So this was the last question. I hope this session was helpful to you. If this session was helpful, if you were able to learn some new techniques or new ways of approaching question, please like the video. You can also share this with your friends. And I have created a playlist where I have solved chapter-wise PYQ question. You can check that out. Any of the chapters where you want to practice more, you can check out those videos because only one day is left. You can practice that. Uh, yes, that's all. If to get the latest updates about the KCET exam, you can subscribe to my channel. Thank you.